Section 2.1 starts to get this concept that is fundamental to pre-calculus study, and that is the concept of a function. What a function is simply stating that each input has, at most, one output. I like to think about it like this, kind of visually. If I've got this machine, and I'm going to call it the f of x machine. If I stick the number 5 into the machine, that's my input, my output might be something like 2. If I stick the number -4 into the machine, my output might be something like -7. And then if I come back and try and stick the number 5 into the function machine again, it should give me out the exact same thing I got out last time. It should give me out a 5 again. That's the idea of a function, is different numbers go in and come out with different outputs, or maybe the same output. But when we put the same number in twice, we get the same output both times. A little bit of vocabulary around functions that we use. First is the domain, is the list of all of the possible inputs. Those are the things that are going into the machine. Over here, that's what goes into the machine. This is the domain, things that go in. Usually the inputs we represent with the variable x, what actually goes into the function. Contrast this with the range, that's the outputs. Often we use the letter y, that's the stuff coming out the other end. This is the range of the function. So domain and range, inputs and outputs. And then special type of functions are called one-to-one functions. And that simply means that each output spell output, right? Each output has at most one input. In other words, if I get 5 as an answer, I'll never get 5 as an answer again unless I use the same input. And we'll get more to that idea later along in the chapter. A couple things we want to be able to do with the function. The first we want to be able to do is evaluate the function. We'll see some notation here that looks something like f of x equals 2x squared minus 4x plus 3. And it's important to note here that f of x on the left side there, that is not f times x. That is a notation that names the function f and has x as inputs into the function. So we're never going to solve for x by dividing by f. We don't do stuff like that. It names the function and tells us what variables are in the function. Essentially, this is saying f of some stuff is equal to 2 times the stuff squared minus 4 times the stuff plus 3. And we're going to simply fill in the stuff. So as an example, using this f of x function, let's find f of -3. This means we're going to take -3 and replace the x's with -3. So we have 2 times -3 squared minus 4 times -3 plus 3. Order of operations tells us to evaluate the exponents first. -3 squared is 9, minus 4 times -3 plus 3. And then we can multiply. 2 times 9 is 18. -4 times -3 is plus 12, plus another 3. When we add that together, we're going to get 33. So we say that f of -3 is equal to 33. In other words, when negative 3 goes into the function, 33 comes out. Let's try another example. It's a little bit more involved, though. We're going to do f of a plus 2. And just by way of reminder, because it's not on my screen, you probably already have this in your notes, though. F of x is 2x squared minus 4x plus 3. So this time we've got this a plus 2 inside the function. So that's what's going to replace the variables. We have 2 times the stuff squared. In this case, the stuff is a plus 2. Minus 4 times the stuff. In this case, a plus 2. Plus 3. Simplifying is going to be essentially identical. First we have to square the binomial. So we square the first term, and then we have the product 2a plus 2a is 4a. Plus 2 squared is 4. Minus 4 times a plus 2 plus 3. Distribute through parentheses gives us 2a squared plus a plus 8. More distributing, negative 4a minus 8 plus 3. Combine like terms, there's only 2a squareds. 8a minus 4a is 4a. 8 minus 8 plus 3 is a positive 3. And we have our final solution, 2a squared plus 4a plus 3. We're simply replacing the variables, the x's, with what stuff goes into the function. So let's look at another one. What number was that? 2? We're on 3 now? Let's find f of x minus 1. And again, it's off my screen. So just as a reminder, we had f of x was equal to 2x squared minus 4x plus 3. So in this case, we're going to take x minus 1 and replace each of the x's. So we have 2 times stuff squared. In this case, it's x minus 1. Minus 4 times stuff, which is the input of x minus 1, plus 3. It's okay that we use the same variable. We're still replacing the x's with whatever the stuff is. Squaring then first, that's order of operations, gives us x squared minus 2x plus 1, minus 4 times x minus 1 plus 3. Distributing through parentheses, that's 2x squared minus 4x plus 2, minus 4x plus 4, plus another 3. Combine like terms on the 2x squared. We've got negative 4x, and negative 4x is negative 8x. And 2 plus 4 plus 3 is 9. Let's do one last of these. Let's find f of x plus h. We can also have several variables going on. And again, the function we said we were talking about was f of x equals 2x squared minus 4x plus 3. And so again, we're going to take the x plus h, and it's going to go into each of the x's. So we have 2 times stuff squared. That stuff is x plus h. Minus 4 times stuff. That stuff is x plus h plus 3. And in much the same way as the previous two problems, we'll simplify using the order of operations, doing exponents first. That's x squared plus 2xh plus h squared minus 4 times x plus h plus 3. Distribute through parentheses, that's 2x squared plus 4xh plus 2h squared minus 4x minus 4h plus 3. And in this particular problem, there really are no like terms. So it's big, it's ugly, but it's right. That is what f of x plus h is going to equal. And we can do all sorts of problems like this, picking any type of function and picking any type of input, number, variable, expression, and just simplify it out. In fact, on the homework assignment, you get a chance to do a lot of that. But I want to look at one special thing that we can do with functions that's going to come up a lot as we continue with our study of math, particularly when you get to calculus, is calculating this thing called the difference quotient. Or the average rate of change between 2 points. I'm going to set this up with a graph. Here's the graph. And I'm going to pick 2 points, one over here on the left and one over here on the right. And to find the average change between those points, we would connect the dots. Now this first point has an x-coordinate of x, and if we plug that into the function, it'll give us f of x for an output. So at x, it has a height of f of x. The second point over here, we're going to say moves over a distance of h. So if we move over a distance of h, that's going to be x plus h for the first coordinate, comma f of x plus h for the height. And we know that to calculate the slope between 2 points, that's going to be y2 minus y1 over x2 minus x1. In this case, y2 is f of x plus h. Minus y1 is f of x. And this is all over x2, which is x plus h, minus x1, which is just x. And that's kind of nice because x minus x goes away. And so we end up with the slope of f of x plus h minus f of x all over h. This thing is called the difference quotient. It calculates the average rate of change between 2 points. So let's see if we can find a difference quotient with an example. Let's do f of x equals 3x squared plus 2x. And we're going to find that difference quotient. Well, for the first part, f of x plus h, we're going to stick x plus h in for the x's. So we've got 3 times x plus h squared plus 2 times x plus h. Next part is we're going to subtract the entire f of x. So we will subtract in parentheses, this is important, when we subtract, we need parentheses, 3x squared plus 2x. And this is all over h. Order of operations is going to have us do the exponent first, so that's going to be x squared plus 2xh plus h squared plus 2 times x plus h minus 3x squared plus 2x in parentheses for that last bit. And that's going to be important because now we're going to distribute through parentheses. Oops, I forgot the denominator, didn't I? It's all over h. As we distribute through the parentheses, we get 3x squared plus 6xh plus 3h squared plus, distribute through the parentheses, 2x plus 2h. And then when we distribute the minus, we get minus 3x squared minus 2x all over h. And this is nice because some things are going to start to subtract out. We've got a 3x squared and a negative 3x squared. Those are gone. We've got a 2x and a negative 2x. Those are gone. So what we're left with is 6xh plus 3h squared plus 2h all over h. But we know we have to be careful when reducing. We must first factor before we reduce. So factor out an h, leaving behind 6x plus 3h plus 2 all over h. And now we can cross off those h's, giving us a final answer, a final average velocity of 6x plus 3h plus 2. That's how we calculate a difference quotient. There's several of these on the homework assignment. Make sure you take a really good look at them and understand how they work. The most common error we see is students forget to distribute the negative through parentheses. Always put that minus f of x in parentheses. And then simplify from there. So that kind of summarizes the first thing we want to do with a function, evaluating a function and a difference quotient. The next thing that I want to do is look at what is called the domain, or all possible inputs. And sometimes it's easier, instead of describing all things that are possible, we'll describe more what's not possible. And so far we've seen a couple things that are not possible. We know we can have no 0 in the denominator of a fraction. We also know there are no negatives in our even roots. Those both will make those functions undefined because we can't divide by 0, we can't take the square root of a negative number. Those make things undefined. So if we have a function like f of x equals 2x minus 3 over x plus 5, and we're asked is 5 in the domain, what we're really saying, can 5 equal x? Can we find f of 5? Well, here we have 2 times 5 minus 3 over 5 plus 5. Well, 2 times 5 is 10, and 10 minus 3 is 7, and 5 plus 5 is 10. Because we get an answer of 7/10, it doesn't matter what the answer is, but 7/10 is a valid answer, we say yes, 5 is in the domain. Let's look, is negative 5 in the domain? In other words, can negative 5 be an input or an x? Can we find f of negative 5? Well, that would be 2 times negative 5 minus 3 all over negative 5 plus 5. Simplifying, we have 2 times negative 5, which is negative 10, minus 3 is negative 13. But negative 5 plus 5 is 0. We can't do negative 13 divided by 0. We can't have 0 on the bottom of a fraction. I think about the word no. What's not allowed? No. 0 cannot be in the denominator of a fraction. No. Because that's undefined, it can't be in the domain. So we answer the question in the negative. Let's try another function. Let's take a look at the function f of x equals the square root of x plus 5. And we're going to look at the question, is negative 2 in the domain? Remember, we can't take the square root of negative numbers. But don't be too quick to exclude negative 2, because if we make that equal to x, if we find f of negative 2, that's the square root of negative 2 plus 5, or the square root of positive 3. Now, it might be an ugly number, but we can take the square root of negative 3. So we will say, yes, negative 2 is in the domain. How about this one? Is negative 7 in the domain? In other words, can we find f of negative 7 and get a valid output? Well, f is the square root of x plus 5, or negative 7 plus 5, which is the square root of negative 2. As we said earlier, we cannot take the square root of a negative number. So no, negative 7 is not in the domain. In fact, rather than looking at specific points, it might be easier to just find the exact domain of a function we're interested in. Let's do the function f of x equals the square root of x plus 1 over x squared plus x minus 6. Now with the domain, we need to look at what's possible and what's not possible. And remember, one thing that's not possible is the denominator. The x squared plus x minus 6 cannot equal 0. Well, if we tried to solve this, we would factor to get x plus 3, x minus 2 can't be 0. And then each factor equal to 0 or not equal to 0. X plus 3 can't be 0. X minus 2 can't be 0. So x cannot be negative 3 or positive 2. Those are outside of the domain. But in this problem, that's not the only restriction, because we have a square root. And we know with square roots, the x plus 1 has to be greater than or equal to 0 because it cannot be negative. Square roots cannot be negative. So x has to be greater than equal to negative 1. Well, if we really look at this problem, the negative 3 is already smaller than negative 1, so we don't really need to worry about that. So to clearly give our domain, we're going to say our domain is x has to be greater than equal to negative 1, and x cannot be equal to 2. That's going to be the domain of this function. One last thing I want to look at then is not just the domain, but looking at range values, or all possible outputs. Another way of thinking about that is all possible solutions. So if we had the function f of x equals 9 minus x squared, we could be interested in the question, is y equals 0 in the range? And when we're talking about range, that means we're going to plug the 0 in for the f of x. In other words, we're saying 0 is equal to 9 minus x squared. Well, we can solve this by adding x squared to both sides. Gives us x squared equals 9, and take the square root, x equals plus or minus 3. So we have two options, but what's important is, yes, we can get 0 for an answer, so yes, y equals 0 is in the range. Contrast that with the question, is y equals 10 in the range? With range, we're plugging it in for the answer, 10 equals 9 minus x squared. And this time, if we subtract 9 from both sides, we get 1 equals negative x squared. Divide by the negative 1, and x squared equals negative 1. And then we try and take the square root. But we can't. We can't take the square root of a negative number. Because we can't do this, we will say no, 10 is not in the range of this function. Let's do one more range problem before we wrap up. Let's say another function, f of x, is equal to x minus 1 over x plus 1. And we want to know, is y equal to negative 1 in the range? Again, we're going to plug that negative 1 in for the answer. Negative 1 equals x minus 1 over x plus 1. Solving, we're going to multiply both sides by the denominator of x plus 1, because it's going to divide out of the right, and we'll distribute on the left. Negative x minus 1 equals x minus 1. Adding x to both sides, getting all the variables on one side. Adding 1 to the other side gives us 0 equals 2x. Don't panic when you see 0. Just keep going. Divide by 2, and x equals 0. 0 is a valid solution. So we say yes, y equals negative 1 is in the range. What about is y equals positive 1 in the range? Well, we'll plug positive 1 in, so we've got positive 1 is equal to x minus 1 over x plus 1. Multiply both sides by the denominator again to clear it of x plus 1. Gives us x plus 1 equals x minus 1. Get the variables on one side by subtracting x from both. Notice x minus x is 0 and x minus x is 0. We're left with 1 equals negative 1. Except it doesn't. 1 and negative 1 are very different numbers, so we will say no, we never got an answer. Y equals 1 is not in the range. So domain, those are the inputs, the x values. Range, those are the outputs, the y values. The other thing we're doing today is evaluating functions at points and expressions, just replacing the variables with the stuff. Take a look at the homework assignment, practice especially with that difference quotient, and we will see you in class.